Have you ever looked up at the night sky and wondered about the mysterious flashes of blue that seem to defy explanation? Since 2018, astronomers have been grappling, witnessing bursts of brilliance unlike anything seen before. These luminous phenomena, known as luminous fast blue optical transients, outshine even the brightest supernovae, captivating astronomers with their elusive nature and perplexing origins. Some appear tantalizingly close, while others twinkle billions of light-years away, teasing us with their secrets. Despite years of observation and analysis, these celestial fireworks remain shrouded in mystery, leaving scientists scratching their heads in bewilderment. Join me on a journey into the heart of this cosmic riddle as we unravel the secrets of space's brightest explosions. We'll delve into the fascinating world of luminous fast blue optical transients, exploring their discovery, decoding their patterns, and pondering the tantalizing question: what could be behind these cosmic spectacles? Being such a recently discovered event, the data we have on luminous fast blue optical transients, or LFBOTs for short, is minimal. The first LFBOT ever detected was identified just 6 years ago in 2018, and we've only witnessed a handful of them since. As so little is known about them, it makes agreeing on a universal definition a little tricky. For now, what scientists do all agree on are some common characteristics these LFBOTs seem to share. So far, they all display a predominantly blue emission, very high optical luminosity, and being bright in X-rays, ultraviolet rays, and radio waves. They're also very fast, as their name indicates. LFBOTs go off like a cosmic camera flash. They reach peak brightness and then dim very rapidly, usually in the space of hours or days. As you might know, a supernova follows the same pattern of brightening and then dimming, but this dimming takes weeks or months. This short-lived nature of LFBOTs makes them difficult to spot and study. So how did we manage to capture such an elusive event? NASA's Atlas HKO telescope stationed in Hawaii serves as a vital component of an early warning system for potential asteroid impacts. This state-of-the-art telescope diligently scans the night sky multiple times, tirelessly searching for any signs of movement. Then, on June 16, 2018, during one of its routine scans, Atlas HKO stumbled upon something extraordinary: a sudden, intense flash, 100 times brighter than the average supernova, vanishing within a matter of days. In an instant, the scientific community sprang into action, meticulously analyzing the captured data to unravel the mystery. Their investigation led them to pinpoint the source of the explosion, the Hercules constellation, situated a staggering 180 million light-years away. Formerly dubbed AT 2018 Cow, this cosmic spectacle affectionately earned the nickname the Cow, inspired by the last 3 letters of its official designation. As researchers delved deeper, they quickly identified it as a Type 1b supernova, typically arising from the collapse of massive stars under their own gravitational pull. However, there was something uniquely puzzling about this particular event that left scientists scratching their heads. When taking a closer look at the Cow's emission spectrum, it didn't look very typical for a Type 1b supernova. It had unusually broad emission lines and very weak helium lines. Scientists thought it appeared more reminiscent of a Type 1 CBL supernova, and so it was quickly reclassified. However, the more scientists pored over the data, the more surprised they were by what they found. Whatever this explosion was, it started to look less and less like a supernova. At least, not the kind of supernova we'd expect. For starters, it appeared out of nowhere. This blast went from inactive to peak luminosity in just a few days. Like we mentioned earlier, supernovae usually take a few months to reach their brightest and dim again at a similar pace. Not only that, it was registered to be 10 to 100 times brighter than an ordinary supernova. Also, everything about the way it exploded was wrong. When supernovae explode, they tend to release their energy in a spherical shape. We know now that the shock waves sent out after a supernova can be aspherical due to the presence of strong magnetic fields which can distort the shape of the initial blast. However, upon closer inspection, this mystery explosion did not even explode spherically. The researchers themselves called it the most aspherical explosion ever seen. Soon enough, other theories were being put forward. Some thought the cow could be a monster black hole shredding a passing star. Others suggested it was a supernova that gave birth to a black hole or a neutron star. But let's step back for a moment. Drawing conclusions from a single occurrence is like trying to solve a puzzle with just one piece. You need more pieces to see the bigger picture. As the old saying goes, one event is a fluke, two is a coincidence, but three, well, that's when you start to see a pattern emerge. Researchers were eager for a larger sample size, craving more instances of these extraordinary explosions to analyze. Fortunately, they didn't have to wait long. Just a few months after the initial sighting in June 2018, the cosmic stage lit up again in September of the same year. Then, like clockwork, another burst dazzled astronomers in 2020. Following the tradition of endearing animal nicknames derived from their official designations, we welcomed the cow, the koala, and the camel to the LF-Bot zodiac. With 3 distinct LF-Bot events under their belt, scientists finally had enough data to start connecting the dots. One striking similarity among the cow, the koala, and the camel was their cosmic address. Despite occurring in different corners of the universe, each explosion originated within the spiral arm of a galaxy. Initially, this seemed to align with the notion that LF-Bots were merely a type of core collapse supernova. But as researchers delved deeper, they uncovered more intriguing clues. Let me explain. The kind of star that causes a core collapse supernova is a massive star, one of the biggest types of stars you can get. And as you know, the bigger the star, the shorter its lifespan. This means that these massive stars don't get the chance to travel very far before they die. It would make sense then that their supernovae occur very close to the star cluster where they were born. And what part of the galaxy is known for having such star clusters? The spiral arms, the exact place we saw all 3 LF-Bots. But just as researchers seemed to be making progress, something happened that caught them completely off guard again. Like the Atlas HKO in Hawaii, the Zwicky Transient Facility is a very wide-angle ground-based camera that scans the whole northern night sky every 2 days. In 2022, it detected another similar explosion. Except after the initial blinding flash, this optical transient started behaving rather strangely. Instead of exploding once and fading away in a few days like the other LF-Bots before it, the so-called Tasmanian Devil continued to produce short-duration bursts far longer than expected. What's more, each of these bursts seemed to be just as bright as the original explosion, which was very strange indeed. Since then, researchers are exploring different dimensions of these activities, and there is more to this research than the details that we shared. If you want to watch the next part of this video, then comment down below, subscribe to Space Episodes for upcoming educational videos related to space science, and press the bell icon. Thank you for watching this video until the end.